back at it with example 2. Sometimes you can compare data without necessarily having to write anything down even. And we'll kind of do that with this one. We'll talk about some of the numbers, but I'm not going to show all of my calculations here. So each girl in Mr. Sanson's class and Miss Kwai's class measured their own height. The heights were plotted on a dot plot below. Use the dot plots to compare the heights of the girls. So first thing I would notice is their range. The range is roughly the same. So the range, yeah, I can't do it this way. I have to swap over and do it with my pen. Sorry, guys. So what's on here? The range for this first one is 72 minus 59, right? So 72 minus 59. Okay, that would be your actual numerical range, or you could say the range is from 59 to 72. You can do it that way. And then the range for this other one is from 60 to 72, or you can calculate it, this being 13, and then 72 minus 60 being 12. So basically, there's a gap of 13 on the top one and 12 on the bottom one. Now, the other thing that you would want to be able to pull from this is it seems to be that the majority of the data for this bottom group for Mr. Kwai's class is between 61 and 67. So most data from 61 to 67. Whereas for Mr. Sanson, seems like most of his data is between 64 and 70. So most data Okay, so the question there becomes, can we pull anything from that information without having to do any calculations? I'm hoping you realize that this means that the mean for Mr. Sanson's class is going to be a little bit higher than the mean for Mrs. Kwai's class, because the majority of your data, first off, the range is basically the same. They're very similar, so the data is not super spread out. But most of the data appears to be on the right side, and down here, most of the data appears to be on the left side. And when you compare the two, it's just not quite as high. So Mr. Sanson is going to have a higher mean. He's going to have a higher median. So he will have a higher center of data. All right. And this is a lower center. You would also call this one, I'm going to write it over here. So this one would be an example of skewed to the right. And this would be an example of skewed left. Okay, because most of your data is on the right side, and you seem to have this little tail over here on the left side. And then on this one, most of the data is here, and you have these 4 dots over here to give that tail on the right side. Okay, so skewed left, skewed right, just examples of what those look like. We talk about variance, or how spread out the data is. We already kind of talked about it. It's clustered like within a 6 or 7 unit window. This is clustered within like a 6 unit window. So your variance, your measures of variance are going to be very, very similar. You could calculate it down and figure out, this one's a little bit more spread out than that one, but just looking at them, I would say that this one is probably going to have a little less variance because this has more dots on the outside of that window that I kind of drew. This one only has like 4 or 5. So again, you could calculate that exactly, but this one's going to have a slightly less variance. Mrs. Kwai's class is going to have slightly smaller amount of variance, or be slightly more consistent. But overall, Mr. Sanson's class has taller students. Okay? So just making some general comparisons there. All right, we're going to flip on to example 3. Sam wants to buy a lottery ticket. There are 2 different tickets he can buy, and each ticket costs $10. He found a website with information about how much money others have won with their lottery tickets. The information is presented in two box plots shown below. Use the box plots to compare the amounts others have won. So what is this really saying? The range of the amounts would be very similar. The range is going to be your max minus your min. So the range of winnings is $25. And for the other one, here's 25, here's 20. So it's like we're halfway through. So that's probably what, 22.5. So the range here is 22.5. So $22.50. Okay. So roughly similar. Okay. Nothing drastic there. So the other thing about these box and whisker plots is that each of these little sections is 25%. Doesn't matter about the size of the box. That just tells you how spread out the data is. It's just 25% of the numbers. Okay. So 25, 25, 25, and 25. All right. So a small box like this means that 25% of the data was between $2.50 and $5. And that means that's a pretty large consistency in that area. Whereas in this area, 25% was between $5 and $17.50. So the same number of people fell within this window as within this window, right? Let's say this was 10 people, they got these amounts, and another 10 people got somewhere in this range, okay? So these were obviously more spread out than these, okay? And so when we talk about, that'll bring us to the IQR, because this is Q1 and this is Q3, Q1, Q3. All right. So more consistently in ticket 1, the IQR, which is the middle 50%. So let's do that. Middle 50%. The IQR would be $12.50 minus 5, so a $7.50 range. And the IQR here is going to be 1750. Sorry, 1750 minus 250, so that would be $15. So we have a much larger range for ticket 2 for the middle 50%. Okay, which means what that means is the middle 50%, kind of the core average group of people, had a range of this, right? They fell somewhere within a $7.50 range. So basically, they were going to make between $5 and $12.50 off their ticket. Whereas this group over here may only get $2.50, or they may get all the way up to $12.50. I'm sorry, $17.50. So they have a higher cap, but they also have a lower cap, which means you got a lot more variance between what you can and can't make there. Whereas here, it's a little easier to guarantee what you might end up with. So the median is the middle of the data set, right? So your median is 7.5, so $7.50. Your median here is $5. So what that tells you is that you're more likely, if you average out these numbers, you're more likely to make more money with the first one than you are with the second one. Even though you have a larger gap here, that median tells you that you're more likely to win more money by choosing ticket 1 than ticket 2. Now, mean and mean absolute deviation can't be calculated here because we actually don't have the data set. We don't have all the numbers. We just have the summary of the numbers. So we have to limit our judgments to range, IQR, and the median. Median being the only real measure of center that we can pull out of this. So final conclusions is he'll most likely win more money with ticket 1. Okay, and that's really focused on that having a higher median and a strong core center, right? Strong middle 50%, consistent. Smaller means more consistent.